Welcome back to another deep dive with us.
It's great to be back.
Today we're diving into something that sounds like it's straight out of science fiction.
Oh, yeah.
But it's totally real, and it's called piezoluminescence.
You got it.
So we're talking about materials that emit light when you squeeze them.
Yeah, so squeezing crystal and getting light.
Exactly.
That's the idea.
And, I think a lot of people are probably thinking right now, well, light bulbs do that when you turn them on.
Right.
This is different.
Very different.
This is about pressure.
Mechanical pressure.
Right,
okay.
electricity.
Exactly.
So we're going to unpack 5 fascinating facts about this phenomenon.
Okay.
Starting with, what is piezoluminescence?
Right.
And how does it work?
Yeah.
Then we're going to delve into a very specific material.
Okay.
Which is called manganese-doped zinc sulfide.
Right.
It's kind of the rock star of piezoluminescence.
It is.
From there, we'll explore how this effect can be used to create stress sensors.
Okay.
Imagine, a bridge.
Yes.
That can tell you when it's under too much pressure.
That's the idea.
Or a building or an airplane.
Right.
Then we're going to talk about pressure-activated lighting.
Very cool.
Imagine a future where your footsteps could literally light up a room.
I like it.
And finally, we'll get into the atomic level and look at crystal structures and how they play a role in all of this.
All right, so let's get started.
So to kick things off,
Yeah.
let's clarify what piezoluminescence actually is.
Okay.
It's not just about, something getting hot and then glowing.
No. It's different. It's distinct from things like incandescence or electroluminescence.
Okay.
Piezoluminescence is specifically about the emission of light due to mechanical pressure.
Okay.
Imagine applying a force to a material.
Okay.
And as a response, it releases that energy as light.
Now, when we talk about the history of this phenomenon, was this something that scientists were actively searching for, or was it more of a, whoa, look at that kind of discovery?
It was a happy little accident.
Oh, really?
Yeah, back in the 19th century.
Okay.
Scientists noticed that certain materials would emit light when they were subjected to pressure,
Okay.
even if they weren't heated
Okay.
or exposed to electricity.
Interesting.
It wasn't something they were expecting, but it sparked a whole new field of research.
So serendipity strikes again.
Exactly.
So let's talk about this star material. You mentioned manganese-doped zinc sulfide.
All right.
What makes it so special in the world of piezoluminescence?
Well, it's one of those materials that really showcases this phenomenon beautifully.
Okay.
When you apply pressure to it, you see a visible glow. It's not just a faint glimmer, it's a noticeable emission of light.
Wow.
Making it, a particularly interesting material to study.
And when you say doped,
Right.
what does that actually mean?
Doping basically means you're introducing a small amount of another element into the material's crystal structure.
Okay.
So in this case,
Yeah.
adding manganese to zinc sulfide, it changes its properties.
Okay.
It enhances its ability to emit light when pressure is applied.
So the manganese is kind of like giving the zinc sulfide superpowers.
You could say that, yes. It's like a little boost.
Now, are there other materials that exhibit this kind of piezoluminescence, or is manganese-doped zinc sulfide the main event?
While manganese-doped zinc sulfide is a great example,
Okay.
it's definitely not the only one.
Okay.
There are other materials out there that show piezoluminescence to varying degrees.
Okay.
They might not be as bright or emit light in the visible spectrum.
Got it.
But manganese-doped zinc sulfide is the one that really stands out for that visible and relatively bright glow.
So I'm picturing myself at a cocktail party.
Okay.
And someone asks me,
Yeah.
hey, what is piezoluminescence?
Right.
And I just pull out a chunk of manganese-doped zinc sulfide,
Okay.
give it a squeeze,
Yep.
boom, instant demonstration.
That's a great visual.
I'd be the hit of the party.
Definitely.
Now let's shift gears a little bit and talk about the practical side of things.
Okay.
You mentioned earlier that piezoluminescence could be used to create stress sensors.
Yes.
So I'm imagining buildings that light up
Yeah.
when they're under stress.
Right.
Like a futuristic warning system?
That's not too far off.
Oh, really?
Yeah. You remember how we talked about the intensity of the light
Yeah.
being related to the amount of pressure applied?
Exactly.
That's the key.
Okay.
You can embed these materials into structures.
Okay.
And as the structure experiences stress,
Right.
whether it's from traffic or wind,
Okay.
or even subtle shifts in the foundation,
Okay.
the intensity of the light emitted changes.
Wow.
And this tells us, about the pressure points
Uh-huh.
and the severity of the stress.
So you're basically giving a voice to the structure,
Exactly.
allowing it to communicate where it's feeling the strain,
You got it.
so potentially preventing disasters before they happen.
Absolutely. Early detection is key.
And this isn't just limited to large-scale structures, is it?
No, not at all.
Okay.
You can use these sensors in smaller applications as well,
Like what?
like monitoring pressure changes in machinery.
Okay.
This is crucial in industrial settings.
To prevent malfunctions.
Exactly, to ensure safety and efficiency.
So this isn't just a cool science experiment.
No, it's much more than that.
It has real-world applications.
Real-world impact.
Now let's step back into the realm of what-ifs for a moment.
Okay.
Okay.
I like what ifs,
And talk about pressure-activated lighting.
right?
Could piezoluminescence actually light up our homes someday?
You know, it's not mainstream technology yet,
Okay.
but researchers are exploring the possibilities.
Okay.
Imagine flooring that illuminates as you walk across it,
Wow.
or walls that respond to touch,
Okay, now that's what I'm talking about.
or even clothing that glows with every move.
That's so cool.
Right.
But let's be realistic for a second.
Okay.
What are the challenges we need to overcome
Sure.
to make this a reality?
Well, one of the main challenges is brightness. Right now, piezoluminescent materials are generally not as bright
Uh-huh.
as LEDs or other conventional light sources. They
Right.
need to find ways to boost their light output.
So it's an efficiency issue?
Yeah, you could say that.
Right.
There's also the question of durability.
Okay.
Can these materials withstand repeated pressure
Right.
over a long period without degrading?
That's a good question.
Yeah, and how do we harness the energy to
Yeah.
create a reliable light source?
Right.
These are all things researchers are working on.
So hurdles, but potential is there.
Absolutely.
Let's bring it back down to the scientific fundamentals for a moment.
Okay.
How does this whole piezoluminescence thing actually work at the atomic level?
All right, so we need to talk about crystal structures.
Okay, hit me with the science.
Okay, imagine a perfectly ordered arrangement of atoms.
Okay?
That's your crystal lattice, the foundation of many materials.
Got it.
Now, when you apply pressure,
Mm-hmm.
you're essentially distorting this lattice,
Okay.
pushing those atoms out of their comfy positions.
So it's like, a Jenga tower.
Oh,
You
yeah.
give it a squeeze, and suddenly all the blocks are a little wonky.
Perfect
Yes,
analogy.
okay.
It's those distortions in the crystal lattice that
Uh-huh.
are key.
Okay.
These distortions store energy.
Okay.
And in a piezoluminescent material,
Okay.
certain atoms can absorb this energy, like this manganese activator, as we talked about earlier.
Right.
And as those atoms relax,
Uh-huh.
they release the energy as photons,
Wow.
which is light.
So you're telling me
Yeah.
that something as simple as pressing on a material can lead to these intricate changes at the atomic level.
It is amazing, isn't it?
And then boom, we get light.
Like,
It's mind-blowing.
it really is a fascinating phenomenon.
It really is.
It's the interplay between the big world of pressure
Uh-huh.
and the tiny world of atoms and energy.
Makes you wonder what other everyday phenomena are
Right.
hiding these intricate scientific stories.
It's a great question.
But that's a question for another deep dive.
Indeed.
So we've covered a lot of ground just now.
We have.
We defined piezoluminescence,
Yes.
talked about that star material,
Mm-hmm.
manganese-doped zinc sulfide,
Of course.
explored its potential in stress sensors,
Right.
and even lighting up our future.
It's a bright future.
And then we took a peek into the atomic world
He did.
to understand those mechanisms at play.
Absolutely.
But before we wrap things up, I have one more question.
All right, shoot. Welcome back to our exploration of piezoluminescence, where we're shedding light on the fascinating connection between pressure and light emission.
It's hard to think about these tiny crystals, their lattices getting all distorted, and then bam, they release that energy as light.
It's like a microscopic rave happening inside the material, with those manganese atoms, soaking up the energy from that distorted lattice and then blasting it out as photons.
And the color of the light, that depends on the material and what's mixed in, right? We talked about manganese-doped zinc sulfide giving that yellowish-orange glow. But could we see other colors depending on what we're squeezing?
Absolutely. The piezoluminescence world is a colorful place. Different materials can emit all sorts of hues depending on what they're made of. Some might give off blue or green light, while others could even emit ultraviolet or infrared, which we can't see with our naked eyes.
So it's not just a one-color show, it's a whole spectrum of possibilities. But let's move past the basics. How can we actually use this phenomenon? Can we build cool stuff with it?
You got it. Let's dive into the applications. We touched on stress sensors and their potential for keeping structures safe, but piezoluminescence has a lot more to offer. It's popping up in fields like medicine, robotics, even energy harvesting.
Okay, now you've got my attention. Tell me more about those applications. I'm especially curious about the medical field. How can piezoluminescence make healthcare better?
Well, one area of research is using piezoluminescent sensors to monitor pressure changes within the body. Imagine tiny sensors implanted that could track blood pressure in real time, giving you continuous readings without needing those bulky cuffs.
Whoa, that would be a game changer, especially for people with heart conditions or high blood pressure. No more constantly checking their blood pressure manually. It'd be like having a built-in monitor right inside you. Are there any other medical applications in the works?
Absolutely. Researchers are looking at using these sensors to detect subtle changes in organs, which could help diagnose conditions early on. And imagine sensors in prosthetic limbs giving feedback to the user about how much pressure they're applying, allowing for more natural movement.
That's amazing. It would totally change how amputees use their prosthetics, giving them a better sense of control. It sounds like piezoluminescence could really transform medicine. But you also mentioned robotics and energy harvesting. How does piezoluminescence fit into those?
In robotics, you could put piezoluminescent sensors in artificial skin. This would let robots feel pressure so they can interact with their surroundings more naturally. That's really important for robots working with humans, especially in tasks requiring a sense of touch.
So robots not just sensing their surroundings, but understanding pressure, almost like we do. That's fascinating. Now, what about energy harvesting? Can we actually get usable energy from this phenomenon?
Piezoelectric materials, close cousins of piezoluminescent materials, can generate an electrical charge when you put them under mechanical stress. So when you apply pressure, they create electricity.
Wait, are you saying that just by walking or even moving, we could generate electricity? That sounds almost too good to be true.
It's a concept with a lot of potential, and researchers are figuring out how to make it work. Imagine sidewalks generating electricity as people walk on them, or clothes powering your gadgets just from your movement. It's a future where our everyday actions contribute to a more sustainable energy grid.
That would be incredible. It would change everything about how we think about using and producing energy. It's like we become walking power plants. But let's be real. What are the challenges?
You're right, there are some hurdles. One big one is scaling up. The amount of electricity these materials make now is pretty small. We need to boost their energy output to make them a real alternative to what we use today.
So it's about efficiency and scale. But if we could solve those challenges, the possibilities are huge. It's inspiring that piezoluminescence, something that started as just a scientific curiosity, could have such a big impact on technology. But let's not forget about the artistic side of this. You mentioned earlier that piezoluminescence could be used in interactive art. I'm picturing a museum with glowing sculptures and floors that light up as you walk across them. Tell me more about how artists are using this unique kind of light.
You got it. Artists are using piezoluminescent materials more and more to make dynamic and interactive art that reacts to touch or movement. It's all about blurring the lines between the person looking at the art and the art itself, letting the viewer become part of the artwork.
So it's not just about seeing art, it's about feeling it, experiencing it physically. What are some examples of how artists are actually using piezoluminescence?
Imagine sculptures that glow in different colors depending on where and how they're touched, creating a personalized light show. Or installations that leave trails of light as people move through them, like glowing footprints that vanish as the pressure goes away.
That sounds mesmerizing. It's like making art come alive, making it react to our presence. It's incredible how something as simple as applying pressure can unlock so much creative expression. It shows how science and art aren't so separate after all. They can inspire each other in beautiful and surprising ways.
Exactly. Piezoluminescence gives artists a unique way to explore the relationship between light, movement, and how people interact with art. It's pushing the boundaries of traditional art forms, creating truly captivating experiences.
Well, we've covered a lot in this part of our deep dive. We've gone from the tiny world of crystals and atoms to the big picture of medicine, robotics, energy, and even art, all thanks to piezoluminescence. But there's still more to discover, and we're back for the final part of our deep dive into the world of piezoluminescence.
Where we've explored everything from glowing crystals to the potential for self-powered cities.
But now it's time to tackle some of those burning questions that you, our listeners, have sent in.
I'm ready, are you?
I'm fired up. Let's do it.
All right, let's go.
Okay, first up, we have a listener who asks, is piezoluminescence the same thing as triboluminescence?
Ah, yes, that's a common question.
I'll admit I get those two terms mixed up all the time.
It's understandable.
Can you clear up the confusion for us?
Absolutely.
Lay it on me.
So both involve light emission, but they're triggered by different things. Piezoluminescence, as we've been talking about, it's all about pressure.
Okay.
Triboluminescence is a broader term.
Okay.
It refers to light generated by any kind of mechanical action.
So like rubbing?
Breaking.
Okay.
All piezoluminescence is triboluminescence.
Okay.
But not all triboluminescence is piezoluminescence.
Okay, so think of like crushing a sugar cube
Yes.
and seeing a spark.
Exactly.
That's triboluminescence.
Yes.
But not necessarily piezoluminescence.
Right, because you're breaking those chemical bonds.
Gotcha.
It's not just the pressure.
Okay, that makes sense.
Good.
All right, next question.
Okay.
A listener asks, are there any practical applications for piezoluminescence in everyday life?
Ooh, good one.
We've been talking about all this futuristic stuff.
Right, the big picture.
But what about right now?
Well, there are actually a few things you might be using already.
Really? Like what?
Ever used a cigarette lighter?
Of course.
Some of those use piezoluminescence to create the spark.
No way. I had no idea.
Yeah, it's true.
My lighter is a science experiment.
It is.
I love it.
Inside, there's a piezoelectric crystal,
Okay.
and when you press the button, it creates a high voltage that ignites the gas.
So cool.
It is pretty neat.
This next question is a bit more technical.
Okay, bring it on.
What's the most efficient piezoluminescent material?
Ah, that's a tough one.
Yeah.
Efficiency, it depends on a lot of things.
Okay.
The wavelength of light, the pressure range, the application.
Right.
But generally, materials based on zinc sulfide,
Okay.
especially that manganese-doped version we've been talking about,
Yeah.
they're considered quite efficient.
In the visible spectrum.
Yes, exactly.
So manganese-doped zinc sulfide, still the champ.
At the champ.
Okay, this next one's fun.
All right.
Can I make a piezoluminescent material at home?
Ooh, DI piezoluminescence.
I know, right?
I love the enthusiasm,
Yeah.
but I wouldn't recommend it.
Okay.
It's not exactly a kitchen table experiment.
Okay.
You need special equipment and chemicals, and safety is always the top priority.
So leave it to the pros.
For now, yes. But
If you want to play around with light emission at home,
yes,
you can experiment with triboluminescence.
absolutely.
There are safe ways to do that.
Right, you can find kits online.
Like what kind of stuff?
Things like sugar or wintergreen lifesavers.
Oh, yeah.
Crushing those can create some cool effects.
I've seen that. That's pretty neat.
It is fun to see.
But yeah, always follow the instructions and safety precautions.
Absolutely. Safety first.
All right, last question.
Hit me.
What's the future of piezoluminescence research?
Ooh, looking ahead.
Yeah, what are the big questions scientists are working on?
Well, there's still so much to learn.
I bet.
One focus is developing even brighter and more efficient materials.
Okay.
Another is making flexible and biocompatible films for medical use.
Right.
And then there's exploring how piezoluminescence interacts with other phenomena.
Like what?
Like magnetism or thermoelectricity.
Very cool.
We're really just at the beginning.
So it sounds like piezoluminescence has a bright future ahead,
I think it's safe to say that.
full of exciting possibility.
Absolutely.
It's amazing to think that something that started with a chance observation
Right. Happy accident.
could revolutionize so many fields.
From medicine to art to energy.
It really is incredible.
It all comes back to curiosity.
And a sense of wonder.
Exactly.
Well, on that note, we've reached the end of our deep dive into piezoluminescence.
Sad to see it end.
I know, me too, but we've learned so much.
We have.
It's a phenomenon that's both fascinating and has real-world implications.
It's the perfect blend of science and practicality.
So next time you press a button,
Or take a step.
or even crack your knuckles,
Think of piezoluminescence.
the light that comes from pressure,
It's everywhere.
keep those questions coming.
Keep exploring.
And until next time, this is The Deep Dive, signing off.